Hello class and welcome to lesson 6.7 sinusoidal applications. Today is we'll be taking a look at the last official lesson in this unit, and the next lesson or the last lesson of this unit will be the review. So this is the last new topic stuff, and actually you'll find today that it's not really new topic stuff, it's just taking all of the things that we've learned, the important key elements of this unit, and tying it into real life applications. All right, so we're taking a look here at the average monthly temperature T in degrees in the Kawartha Lakes was modeled by, and as soon as I see an equation, guys, I'm going to relate all the things I know in terms of A, K, D, and C. So looking at this expression here, I noticed that A equals 22. I noticed that K equals 30. I noticed that D equals 3, and I noticed that C equals 10. And hopefully that'll help us to use that information to answer some of the questions below. Now I'm going to finish the word problem where T represents the number of months. Just remember that for T equals 0, that's the month of January. And if you're looking for the month of February, that's T equals 1, it's February, and so on. Okay, now it says to answer the following questions. What is the period for this function? So what letter represents, what letter A, K, D, or C is used to help us find the period, and that's the letter K. So just remember that the period equals 360 degrees divided by the absolute value of K. Okay, and that's going to equal 360 degrees divided by our K, which is 30. Okay, so, and I guess, ladies and gentlemen, this problem doesn't deal with degrees because it deals with months, so I can actually just get rid of the degrees in this case. Okay, so it's going to equal 12. Okay, so the period for this is 12, and it says explain what the period represents in this question. Well, hopefully you recognize 12 is an important thing when we're taking a look at the average monthly temperature. So if we've got 12 months, that means in one cycle it's a year. So what does it mean in terms of the context of this problem? There are 12 months in a cycle, and in this case our cycle is of 1 year. Makes sense. All right. Now it asks us, what is the maximum and minimum temperature? So remember, we know that the maximum, ladies and gentlemen, equals our C plus our absolute value of A. So looking up top, C is 10 plus our amplitude, or A, which is 22. So our maximum temperature is 32 degrees. Okay, and our minimum temperature equals C subtract absolute value of A. So that's going to equal 10 subtract 22, which equals negative 12 degrees. Now remember, folks, this isn't the temperature outside. This is the temperature of the water. Okay? And then because it's a word problem, we're going to say, therefore, max temp is 32 degrees. And make sure you put down your unit Celsius. And min temp is negative 12 degrees Celsius. All right. Taking a look at the next question, what temperature would you expect in September? So all we need to do is to remember September is actually what month? Remember the rule here. January is 0. So if you count with your fingers, February, March, April, May, June, July, August, September, that would tell me that T for the month equals 8. Okay, so what we're going to do is replace wherever we see a lowercase t, we're going to put in 8. So just plug it in your calculator. So it's going to be T at 8 equals 22 sine, opening bracket, 30 times 8 subtract 3, plus 10. Okay, plug it into your calculator, and you should get 21 degrees. So therefore, you would expect a temperature of 21 degrees Celsius in September. Okay? Sorry, guys, I have a cold there. Apologize for that cough. All right, keep moving on, as our handout says. Sketch the graph on the provided grid. All right, so taking a look, hopefully we realize that our dependent variable, ladies and gentlemen, is temperature. So we're going to write down temperature here, and it's in degrees Celsius. And our independent, or our x-axis, is going to be time, and that's going to be in months. Okay. And although I have an old scale here, I think on your handout you have a better scale. So I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. Okay. So 12, 13, 14, and 15. So hopefully you end up at 15 months there. All right, and a good title for this, guys, would be lake temperature, or you could do Kawartha Lakes or K-Lakes temperature. Okay, as long as you've got a title on there. All right, so what do we know? What are the basics that we know? All right, well, we can remember, guys, that we already know our AKDC. So let's just recall that A equals 22, so that's our amplitude. Okay. We know that K equals 30, and what that leads to is our period of 12, right? So that tells us that the period equals 12. We know that D equals 3, and that's going to be our start. That's where we're going to start our box. And we know that C equals 10, and that's going to give us our axis. So I'm going to start with that, ladies and gentlemen. So at 10, if you haven't already drawn it in, let's draw that in. That's your axis. Okay? And because it's a sine curve, ladies and gentlemen, and it tells us that we're going to start at our axis for sine at 3, I'm going to put this as my starting block. It's going to be my initial blocks that I'm going to draw. And if I start at 3 and I have a cycle of 12 months, so 3 plus 12, that gives me 15. So that's where I'm going to end my cycle. Okay, so there's my box. So what do I know? I know that it's going to start because it's sine at the axis, and it's going to end at the axis. I also know halfway between that at 9 months, it also has to be at the axis. All right, now halfway between 3 months and 9 months is 6 months, and at 6 months it goes to its maximum. And our maximum, as we've already calculated up there, equals 32 degrees. So at 6 months, let's go to 32 degrees. So I've got 30, 32 right here. Okay, and then we know that our minimum, which is going to be halfway between 9 and 15, which is 12, is going to be at negative 12 degrees Celsius. Okay, so at 12 months, we're going to go to negative 12, coming along here. All right, so that's enough information, ladies and gentlemen, to draw one cycle of this situation. Okay. However, we know that this is going to drop to its minimum in another what? In another 4 months. So at 4 months down here, we're also going to be at negative 12. So we can just finish it off like there. Okay. Because every 4 months, that's where we're having a change. All right, and there's your graph, ladies and gentlemen, okay? So just remember, we use the axis to help us get started with the D value, and then we knew it was a sine. It was the base of the sine function, so we had to go up to its maximum, back down to its minimum, and we could draw a graph. All right, if you have any questions with that, please come see me. Let's move on to the next page. All right, a Ferris wheel. I like these ones, and these are most commonly application questions for this unit. A Ferris wheel has a diameter of 30 meters. Okay, so the diameter of 30 meters will tell us a couple things. First of all, if we take half of the diameter, we know that R, or radius, equals 15 meters. Okay, and if the radius is 15 meters, therefore we know the amplitude equals 15 meters. Okay, because that's going to be the change from your maximum to your minimum. It's going to be 30 total, but to get your amplitude, it's going to be half of that, which is 15 meters. All right, so people get on the Ferris wheel at ground level. Hey, that makes it nice. So at ground level, okay, or a height of 0 meters, that's awesome. Okay, and for a person to make one trip around the Ferris wheel, it takes 40 seconds. So what does that tell us, guys? That tells us the period. So the period for the first question is 40 seconds. And says to answer the following. Well, we just answered the first one. What's the period of the ride? And it's 40 seconds. What does that mean if we're asked for applications? That just means that's the time it takes to complete one ride on the Ferris wheel. So what do we know, folks? We know that we're starting at 0, because that's our initial height when we get on. We know that the period takes 40 seconds, so at 40 seconds we're also going to be back down at the starting position. And if we take another 40 seconds, we're going to be back down there. And that is our absolute minimum height. If we know that the radius is 15, that means that, and we start at 0, that means our axis has to be at 15. So let's just draw that in. Hopefully I can use a nice dotted line here at 15. Okay, so at 15, that's going to be our axis. Okay. Okay. And what do we know about this function? We need to reach our maximum height. So our maximum height is going to be 30. And it's going to occur halfway between. So at 20 seconds, we're going to be at our maximum, which is 30. Let me double check here. I think I've got it right, lined up. Okay. Likewise, the same at 60 seconds, we're also going to be at 30, at our maximum. All right. So taking a look, that's going to be a minimum. It's coming up to a maximum, coming back down to a minimum, coming back up to a maximum, and back down to a minimum. So again, there's your graph, ladies and gentlemen. Okay. And if you were concerned about showing your box, we started at 0. Okay. And it took us 40 seconds to complete. So there's your box that shows one cycle. All right. Everybody okay with that diagram? All right, let's use that to help us answer some questions. Okay. What is the amplitude of the graph that you sketched in part B? Well, we already calculated that the radius equals the amplitude. So that equals 15 meters. And when I'm talking about radius, I'm talking about the radius of the wheel. Okay, if you're not sure, remember radius equals diameter divided by 2. So R equals 30 divided by 2, which equals 15 meters. All right. What is the K value for the graph you've sketched? Remember, K equals 360 divided by the period. Okay, so K equals 360 divided by 40. So K equals 9. Okay. All right. And if they asked you what that transformation meant, ladies and gentlemen, you would say it's a horizontal compression by a factor of 1/9, right? Remember, you have to do the 1 over absolute value of K. All right. E, develop an equation to model this. Now, it doesn't say you have to do 2, but in some cases, if you want to do 2, you can. What do we know already? We know that K equals 9. We found that out. Okay. We already know that the amplitude, we know that amplitude equals 15. Okay. We know that we're starting at 0 because there's no shifting. And we also know that the axis is at C equals 15. The thing we've got to be careful here, folks, is how we address this amplitude. Because when we look at our graph, ladies and gentlemen, we're starting at our minimum, down here, starting at our minimum, and we're going to our minimum. That is not the base function for sine or cosine, but it's the inverse of the cosine. Because remember, cosine usually goes maximum to maximum, whereas this case it's minimum to minimum. So what does that tell us? It's reflected the x-axis, or your axis. So what we have to do is we have to remember that it reflects x-axis because it goes min to min, not max to max. So what we need to do is when we develop A, we've got to make A equal negative 15 because we start at our max, okay? Sorry, we start at our min as opposed to our max. So now we've got all the letters figured out. Now we can put it in, okay? So we're going to use the general formula, and we're going to go y equals A, which is negative 15, cos of k, which is 9, times x. D is 0, so you can use the small brackets or big brackets there. It doesn't matter to me. Plus c, which is 15. So there, ladies and gentlemen, is an equation to model that graph. You could have also, ladies and gentlemen, started and done sine. If you wanted to, you could have done sine here and just calculated your distance of starting at 10, or at 12, I guess, okay? So you could have done that as well, if you wanted to, okay? And I think actually if we did it, if I had drawn this a little more accurately, let me see. If I had drawn this line a little better, I think you would see that it does actually cross at 10. I just didn't round that out very well, okay, guys? Yeah. So let me fix that up a bit. Yeah. So if you did want to do a sine and keep it positive, you could do it here. Okay. So if by chance you did sine, you would go y equals 15 sine of 9 times x minus 10 plus 15. All right, ladies and gentlemen. So again, you could use, there's multiple answers depending on what you wanted to do. Okay? All right, let's take a look at the last page. Okay? All right, last page. Oh, poor Don. Don is a fictional character in a Spanish novel, and he likes to attack windmills, thinking they are great giants. At one point, he got snagged on one of the blades and was hoisted into the air. The graph shows his height above the ground in terms of time. So, ladies and gentlemen, the function is explained by a graph. So from that, we're going to try to find our A, K, C, and D, or whatever information we can to help us get that. And then that'll help us to get to an equation. All right. So looking at the graph, ladies and gentlemen, poor Don who got stuck on that windmill. If we look for the maximum, ladies and gentlemen, up here, you should notice that the maximum equals 14 meters. Okay, what else do we know from a graph? We know the minimum here. Okay, so his minimum is at 2 meters. Okay, and if we want to find the axis, ladies and gentlemen, our axis is going to be right there, halfway between there. So you could take it, to find your axis if you're not sure. So it equals max plus min divided by 2. So it's going to be 14 plus 2 divided by 2. So your axis is going to equal 8 meters. So you can draw that in. All right. So far we've got some pieces of information. Another thing we can think about, folks, is our amplitude. So if we have our max and we subtract our axis, so to find amplitude, that equals max subtract axis. You already know our max is 14. We're going to subtract our axis, which is 8. So that equals 6 meters of amplitude. Okay. The next thing we can figure out is how long does it take for him to complete one revolution? Okay. So taking a look, if we go from 0 to 18, that tells us we have a period of 18 seconds. Okay. What I also want you to note, folks, is taking a look at this graph. If we're to do an equation, we're starting from our minimum to our minimum. So if we're looking for a base function here, guys, Normally we go max to max for cosine, but we're going min to minimum. So I'm going to automatically put down y equals negative cos x. So I know that I'm starting with a it's reflected the x-axis, so I know my a is going to be negative if they ask me for the equation. I just have it there just so that I know I've already recognized it. It's going to be some helpful information. So notice, ladies and gentlemen, we can get a lot of information when a function is delivered in a graph. So let's take a look. What is the equation of the axis of the function? So we've already calculated that the axis is y equals 8. Okay, we already know that. And what does it represent? Well, this represents the axle, where it spins, guys. So the axle is 8 meters high. It's the center part, or the center of the spoke of the wheel, if you're trying to think about what the axle is. Okay, some people also call it a hub, I've heard. Okay. All right, next one. What is the amplitude of the function? Well, we already calculated the amplitude is 6 meters. And what does that tell us, folks? That tells us the length of each blade. Okay. All right, next question. C. What is the period of the function and what does it represent? So what do we know? We know that the period equals 18 seconds. Okay. And what does that represent, folks? That's the time it takes to complete one revolution. Okay. So just one revolution, right, guys? All right, D. What transformation would generate the period for this graph? Okay. So what we have to realize is we're asking about the period. Okay. So what letter in our transformation deals with period? And hopefully you recognize that to be K. Okay, so let's find out K. So K equals 360 divided by the period. Okay, and so it's going to be 360 divided by 18, which equals 20. Okay, so what does that 20 represent, guys? That is a horizontal compression, because that's the transformation, guys, by a factor of 1 over 20. Remember, it's when you're doing by the factor, it's always 1 over the absolute value of K for the factor, okay? All right, keep going on here. We're almost done. And I've got one more to add at the end, okay? That's not written down. Determine the equation of the sinusoidal function. Well, what information do we already know? We've calculated that K equals 20. We've got that. We know that C equals 8. We've already calculated that. We know we're going to start at time 0. But what we have to be careful at is the amplitude. We know the amplitude equals 6. However, remember our base function is negative cosine. So since we're going to use, since it's going min to min, therefore A is going to equal negative 6. Okay? All right. Okay. So let's put our formula in. So we're going to go y equals negative 6 cos times K, which is 20, x plus 8. Okay. Now, ladies and gentlemen, that's the equation of a sinusoidal function. Let's rewrite it in terms of the graph. So instead of y, we're going to have h at t. Okay, equals negative 6 cos 20t plus 8. And the reason I wrote it like this is because this relates to the specific word problem. Okay, so if you can, try to put it in with the measurements given there. Okay. F. If the wind speed decreased, how would that affect the graph of the function? Okay. Well, remember, if we decrease the speed, if it goes slower, it's going to take longer to do one revolution. So a longer ride, if you want to talk about it that way. Okay. So therefore, the period will increase. Okay. So that's telling me about the graph. But what effect will it have? That means if the period will increase, that means what are we doing? We're actually stretching in a horizontal direction. So therefore, we're going to have what's called a horizontal stretch. Okay, so that's describing that transformation there. All right. G. If the axle for the windmill were 1 meter higher, what effect would that have on the function? Well, let's just say if the axis, if we were 1 meter higher, okay, so instead of having our axis at 8, it would now be at 9. So axis would be at 9 meters, okay? So therefore, we would have y equals 9 for our equation of axis, which means we're going to do a vertical translation up 1. Okay? I'm going to add one more question in here, guys. It'll be helpful for you to do it here so that when you do some of your homework questions, you're going to have it. So please fill this in some spot on your handout. H. Calculate the speed of the windmill. And you can expect to have a question like this on your test too. Okay, well, first of all, speed, we have to remember, is distance over time. Just think of when you have the speed limit on the road, okay? So it's distance over time. Okay, and the distance, ladies and gentlemen, is what we call the distance around a circle, which is the circumference of the circle, divided by time. In this case, the time to do one period, or sorry, one time to do one revolution is the period. So in this case, we know that it's going to be 2 pi r, because that's circumference of a circle, divided by whatever the period is. Okay, so I would put that in a box. Make sure you know that for your test. Okay. All right, so what do we know in this case? So speed equals, okay, 2 pi, what's my r in this case, guys? My radius is 6, divided by my period, which is 18. So it means 12 pi divided by 18. Do your calculations, and that's going to give you, I believe, something like 37.69 divided by 18 if you've done the numerator. So it should be 2.1 meters per second. So if you can do a therefore statement, therefore speed of windmill is 2.1 meters per second. Not that fast, lucky for Dawn. All right, ladies and gentlemen, this concludes your lesson for today. Here's your homework, page 398, numbers 1, 3, 5, 8. Try 10 and 13. They're a little tricky. And again, get ready for an upcoming unit test, ladies and gentlemen. And if you need any help, as always, come and see me. Have a fabulous day, guys. Enjoy.